Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P1009, relates to a malfunction in the Variable Timing Control, VTC system, which is crucial for optimizing engine performance and efficiency. The VTC system adjusts the timing of the intake camshaft according to engine demands, allowing for improved torque at low RPMs and enhanced power at high RPMs. This issue can manifest through various symptoms, including reduced engine power or unusual engine noises. It's important to note that this code must be addressed promptly to prevent further engine damage or performance issues. The troubleshooting process involves several steps, including visual checks and operational tests, which are methodical and designed to isolate the problem effectively. Key components involved in this troubleshooting include the VTC strainer, oil control solenoid valve, and actuator, which are integral to the VTC system's functionality. DTC P1009 indicates an issue with the Variable Timing Control VTC advance mechanism. This fault can prevent the engine from achieving optimal timing for valve operation, which hinders efficiency and performance. The VTC system is integral for managing how the engine breathes, adjusting the timing of the intake valves based on various conditions. The critical components include the VTC strainer, located within the engine assembly, and the VTC actuator, both of which are necessary for proper functioning. Failures in these parts can often lead to oil control issues within the VTC system, which can trigger this error code. Understanding the location and function of the VTC components is essential when diagnosing code P1009, as effective repairs depend on identifying the root cause within the system. Several factors can lead to DTC P1009 being triggered in a Honda Civic. A clogged VTC strainer is one common cause. When the strainer becomes obstructed by debris or contaminants, it restricts oil flow necessary for the VTC system to operate correctly. A faulty VTC oil control valve can also lead to this malfunction. If the solenoid does not open or close properly, it will not regulate oil flow as needed for the camshaft timing. Lastly, defects in the VTC actuator, which physically alters the position of the camshaft based on oil flow, can contribute to the error code. Each of these components plays a pivotal role in the VTC functionality, and diagnosing which one is malfunctioning is critical for effective repairs. The presence of DTC P1009 may manifest through a variety of symptoms that drivers can experience. A noticeable reduction in engine power often occurs as the VTC system fails to optimally adjust valve timing, affecting overall performance. Unusual engine noises, specifically from the timing chain or camshaft area, can indicate an underlying issue contributing to the malfunction. Additionally, the check engine light will illuminate in the instrument cluster, alerting the driver of a potential problem within the engine management system. If ignored, these symptoms can escalate into more severe engine issues, hence the importance of early diagnosis. Monitoring the engine's behavior can provide vital information for technicians in pinpointing the specific issue related to the VTC. Begin troubleshooting DTC P1009 by turning the ignition switch to the on position, also referred to as the II position. This action powers up various electronic systems, enabling diagnostic tools like the Honda Diagnostic System, HDS, to function. Next, use the HDS to clear any stored DTCs. This step ensures that only current information is analyzed, providing clarity in troubleshooting. After clearing the DTCs, start the engine and monitor the HDS display for any pending or confirmed DTCs that may reappear. If DTC P1009 is still indicated, this confirms that the problem persists. leading you to proceed to the next troubleshooting step. If the code does not reappear, it may suggest an intermittent fault, and further observation of the vehicle's performance is advisable. For the second step in troubleshooting DTC P1009, first, turn the ignition switch to the lock position, which is also referred to as position 0, essentially powering down the vehicle's electrical systems. Next, carefully remove the auto tensioner, which is responsible for maintaining tension in the timing chain, allowing access to the VTC strainer. Once the auto tensioner is out of the way, proceed to remove the VTC strainer labeled as A. This visual inspection aims to detect clogging or obstruction within the strainer, as a clogged strainer can severely impede oil flow. If the strainer is found to be clean and unobstructed, it confirms that this component is functioning correctly, prompting the next step in the troubleshooting procedure. Should clogging be evident, take immediate action to clean the strainer and replace the engine oil and oil filter as necessary. The third step involves checking the operation of the VTC oil control solenoid valve, a crucial component in the VTC system. This solenoid is responsible for regulating oil flow to the VTC actuator, affecting camshaft timing and operation. Use appropriate diagnostic tools to test the solenoid valve for proper function. An insufficient response indicates the valve is faulty. If testing confirms that the VTC oil control solenoid valve is in working order, resultantly, move forward to step 4. However, if the valve is found defective, the solution is to replace the solenoid and follow it up with repair verification. Ensuring the solenoid's functionality is essential as it directly impacts the effectiveness of the entire VTC system. During the fourth troubleshooting step, the VTC actuator is inspected for any signs of damage or malfunction. The actuator's role is to adjust the camshaft position based on the oil flow, allowing for precise timing of valve openings and closings. A visual and functional inspection should help ascertain whether it is operating as expected. If the actuator appears to be in good condition, the next step is to check the system oil passages for any clogs that may have developed. Should the actuator, however, be found faulty, it must be replaced before moving forward. Proper actuator operation is critical to achieving optimal engine performance, meaning defects here can directly lead to the problems indicated by DTC P1009. After completing all necessary repairs related to DTC P1009, the final repair verification must be conducted to ensure that everything is functioning correctly. Start by turning the ignition switch to the on position, thus powering up the engine control module, ECM. Use the HDS to reset the ECM, which erases any old learned characteristics and allows it to recalibrate based on the changes made. Next, perform the ECM idle learn procedure. This step is vital for the ECM to adjust to new operating conditions accurately. Subsequently, execute the CKP, crankshaft position, pattern clear and learn procedure to synchronize the engine timing after repairs. Lastly, run the VTC test via the HDS to confirm system functionality. Monitoring the onboard diagnostics OBD status for DTC P0011 will determine the status of this troubleshooting process, indicating whether the repairs were successful. Preventive maintenance is key to minimizing the chances of encountering DTC P1009 and ensuring long-term engine health. One essential aspect is to regularly change the engine oil, as fresh oil helps keep the VTC system clean and functioning smoothly, preventing clogs that could trigger faults. It is equally important to perform periodic inspections of VTC components, notably the strainer and actuator, to catch any potential issues early. Additionally, after any repair or maintenance, clearing DTCs is crucial to reset the engine control module, ECM, and monitor for new codes that might emerge. Being proactive in these maintenance routines not only extends the life of the engine's VTC system, but also enhances overall vehicle performance. In summary, diagnosing and resolving DTC P1009 is essential for maintaining optimal engine performance in Honda Civics from 2011 to 2015. Following a structured approach to troubleshooting, which includes verifying problems, conducting component inspections, and performing operational tests, significantly enhances the effectiveness of repairs. Recognizing the symptoms associated with this DTC can lead to early intervention, thus mitigating potential engine damage. Furthermore, establishing a regular preventive maintenance routine ensures the long-term functionality of the variable timing control system. Ultimately, prompt diagnosis and repair, combined with diligent maintenance practices, are paramount for sustaining vehicle reliability and performance. Please like and subscribe to the channel. See you next time.